boys and girls, here we go. P5, our last section. But unfortunately, once again, we're going to have to make this into 2 videos. This is our final topic in Chapter P, which is a review topic. But what we found is that there are a lot of things in there we needed a little refreshment on. And this is our last section. This is on solving all kinds of inequalities. Remember, I told you this is a college text, and you can tell because they jam all of these topics, which would probably take you 2 weeks in Algebra 2, and they put them all in one section. So we're going to break it into 2 videos. Hopefully we can get everything we need done in that time. The topic is solving inequalities. We've been working on all kinds of equations. So this is solving inequalities, and we'll break them down into 2 videos. The first one's linear double and absolute value, and the second one's polynomial and rational inequalities. So let's get started. This is a linear, a linear inequality. And what that means basically is it only has first degree, just x, no x squares. We'll talk about those as we move on. So this is a linear inequality. Notice it has a less than. There are 4 inequality symbols: less than, greater than, less than or equal to, greater than or equal to. Let's solve this. 4 times x is 4x, plus 4 times 4 is 4, is less than 2x plus 3. We're going to solve it just like we normally solve an equation. We're going to bring our x's together, so this would be 2x is less than, and we're going to bring our 4 to the other side. 3 minus 4 is negative 1. We're going to divide by 2, and our answer is x is less than negative 1/2. Now, when you work with inequalities, sometimes you want to show a graph, because a graph is a picture of an answer. And what we know is that this is an infinite set of points. There are an infinite set of numbers that are less than negative 1/2. So what we might want to do is we might want to show that solution on a number line. It would look like this. This is negative 1/2. And we would say less than that, so we've got a circle, an open circle, and we're shading to the left. Now this is the way to show the answer when we were in elementary school or in junior high. We've gotten a little more sophisticated since then, and we have something called interval notation. So another way to show this answer would be to say that it stretches from negative infinity up to negative 1/2. And notice we don't want to count negative 1/2, so we will leave our bracket open or soft. If we did want to count the 1/2, we would put a hard bracket. So this is a linear inequality. The solution fits on a number line, linear. It has no squares, no quadratics, no cubes, nothing, just a plain x to the first power. And the solution is an infinite set represented by either this graph or this set of interval notation, which says all solutions from negative infinity up to, but not including negative 1/2. All right, let's move on to our second question of the day. This is a double inequality. And all a double inequality means is that we put 2 together. We squeezed them together and made 1. Notice it will be highlighted by these 2 inequality symbols. It's 2 that have been put together into 1. So the first thing I'm going to do when I go to solve this is I'm going to split it back up. I'm going to take my first inequality, 0 is less than 2 parentheses x plus 4, and then I'm going to move over, and I'm going to take the second one. 2 parentheses x plus 4 is less than 20. So I took what they had put together in one single inequality and split it back up. Here's the first one, here's the second one. Now when we solve this, 0 is less than 2x plus 8, negative 8 is less than 2x, and divide by 2, and negative 4 is less than x. Or, if you like to read from the x, or x is greater than negative 4. Same thing. I just like to read it from the x. And so then on the other side we have 2x plus 8 is less than 20, and 2x is less than 12, and x is less than 6. Now, remember, anytime you have a double inequality, anytime we've squeezed two parts into one, we have what we're going to have as a joined inequality. And the only way to do that is for the solution to be in between two particular numbers. Here is the graph of this particular solution. Here's negative 4. Here's positive 6. We want to be greater than negative 4 and less than 6. So I like to call this a barbell or a dumbbell shape, two circles with a stick in the middle. And anytime you have one of these double inequalities, it should graph to be this. That's an and situation. And from an integral point of view, interval notation, it would look like this, negative 4 to positive 6, and both of them open. So that's describing the solution set of this double inequality. If you have an inequality that graphs like this, whatever it is, like that direction or this direction, which those are also common, that cannot be written in double form. So this will never appear as a double inequality. It will be two separate inequalities strung together by the word or. Okay, so if you have a double inequality, my advice would be to split it into two, solve each one separately, and then look for a graph that looks very similar to this, shading with two endpoints. Okay, that's the double. Moving on. Yesterday, or whenever we watched it, you had absolute value equations. And now today we're going to spend just a minute talking about absolute value inequalities. We're going to use the same technique we used before, which is, let me remind you, copy what's in the bars, copy exactly what was given to you in the problem. Then copy what's in the bars. Now this is inequality, so we got to do a little different. Reverse the symbol and change the sign. Okay, notice we reversed the symbol. It went from greater than or equal to less than or equal to, and this went from positive to negative. So it's kind of the same idea. Just remember that whenever we change a sign, we have to reverse a symbol. Okay, so x is greater than or equal to 24. X is less than or equal to, we add 20 to negative 4, we're going to get 16. And absolute value means distance. So you can always predict what the graphs of these are going to look like if you read it like this. The distance from this is greater than 4. The distance is greater than 4. So when you imagine if you are in the middle of this little segment right there, and your distance is greater than 4, you're going to have a piece here greater than 4, and you're going to have a piece here greater than 4. So this greater than is always going to produce one of these, an OR statement. Now let's see if this one works. Greater than or equal to 24 looks like this. Less than or equal to 16 looks like this. So it was predictably, if this absolute value is a greater than absolute value, you're going to get the two-part graph. And this is what that looks like from interval notation. You'd go from negative infinity up to 16, hard bracket, in union with 24 to positive infinity. Remember, our infinity always has a soft bracket. And this is split. This is saying there are two parts to the answer. They don't overlap. There are two parts to the graph. And that happens whenever you've got a greater than, an absolute value that is greater than. Now let's go to the second problem, which you can see right here. Let's follow the same procedure. 1 minus 2x is less than 5. We're going to copy it exactly. Or we're going to do 1 minus 2x is greater than negative 5. Now let's solve. Negative 2x is less than 4. Divide by negative 2. You're going to get an x. You're going to get a negative 2. And because you divided by a negative, you're going to reverse the symbol. X is greater than negative 2. Now on this side, negative 2x is greater than, add 1, negative 4. We're going to divide by negative 2. That's going to give us an x. That's going to give us a 2. And and that's going to reverse to less than. Now, I think again about the absolute value being distance. Distance less than 5. If you are here and you want to measure all the things that are less than 5 away from you, you're going to have this part and this part. So they're going to come together, and so it looks kind of like that. So we would expect a graph to look like that. Here's -2. Greater than that's going this way. Less than 2 is going this way. And there's that same graph. This is an AND graph or an overlap. Alright, that's all for this video. We'll pick up on the second part, and you will see it on the second part of P5.